Very good afternoon. Myself, Dr. Ravi Kumar Poluru. So today's topic is model-based software architectures, a management perspective. So here we are going to discuss in two perspectives. So one is management perspective and another one is the technical perspective. So we'll discuss today management perspective, and today we are going to discuss in detail about how the management perspective will be there according to the architecture. So we know that in the model-based software architecture, so architecture is the main is the heart of the project. So here, whatever the problem existed, so mainly this is very critical problem for the any project, because in the initial stage only they need to develop the architecture. So the first one is, so they need to have the what are the requirements. Okay, so the next one is planning is very important, and the most important criteria for any project in the initial stage, the management and the team, they need to design the architecture. So here the architecture is very important. So architecture, or we can call as the design part. After the design, they will go for the implementation. So after the implementation, we know that deployment. Okay. So here, today we are going to discuss the management perspective related to the model-based software architecture. So we know that the software architecture is the central design problem. So this is the main problem which we are going to face during the initial stage or in the later stage. So if they design the software architecture very well, there is no problem at all. If any problem persistence during the project, so they need to change the different types of the components. So that's why the software architecture is consisting of some design problems, because they need to choose the components in a proper manner. If the components they're not using the accurate components while they're designing the architecture, so they may face the complexity while they're designing the software system. So that's why the architecture can call as the central design problem for the complex skyscrapers. So they need to focus more on the software architecture. So they need to check that what are the main dimensionality, like whether it is a one dimensional or two-dimensional, or we can call as a multi-dimensional. If it is a multi-dimensional, they need to take the different types of the criteria, metrics such as the performance. Okay, so they need to consider the what is the performance and adaptability, and mainly they need to check that what is the completeness, and they're going for the multi-dimensional completeness. And they need to check that what is the availability also they need to verify with. Okay, all this will be comes under the what is the quality of the software architecture. So that's why the software architecture is going to verify that the dimensionality of the complexity based upon this matrix. So they can tell that what is the quality of the architecture based upon this matrix. So that's why when they are deciding that whether it is a one-dimensional, two-dimensional or multi-dimensional. Okay. Now when they are considering here the architecture for the large building, means when they are taking the complexity of the architecture, the design part, they need to check that what is the critical performance attributes, means various metrics. So we have seen that what are the performance metrics such as the availability, completeness. Okay, so and what is the adaptability of the computer architecture. Okay, and they need to check that various features according to the complexity of the software systems, and they should not have some stable laws of physics here, and they need to accept some form of mathematics. Sometimes they may be or they may not be accept some form of the mathematics when they are going to design the architecture. And also we have the software architects have no irrefutable first principles. So they need to check that what are the main principles while they're designing the software architecture. So here we have some approaches. One is heuristic approach and another one is fuzzy guidelines. So based upon that heuristic, we know that heuristic and meta-heuristic approaches will be, so compared to the heuristic, the meta-heuristic approach will be performing very well, and they're going to have the architecture in a proper manner. And here the fundamental measures, so they need to check that what is the measurements of the software architecture. So based upon that, they will tell that what is the goodness based upon the situations. It depends upon the situations whether it can be acceptable or not. And also the lacking established theory. So based upon the software architects, some may be how the experimentations based upon the software architecture foundations. Okay, so here we have the one more reasons. One is it will be translation to the iterative process. So they need to check that we have the traditional, okay, so traditional model will be there, and another is iterative process will be there. Mainly we know that, so with the help of the traditional, so we are facing a lot of complexity based upon the cost and the time. And here in the iterative process, we can check that what is the issues during the designing the software architecture, and they need to check that what is the main activities will be performing based upon the prototype as well as the demonstrations. The iterative process, mainly they are going to check that the demonstration will be the main part, because why they require the demonstration by the person means they need to verify that this architecture will be supported to the project or not. So that's why every review meeting they will be checking that during the demonstration they will be inspect that whether this architecture will be facing any issues or not. If they're not facing any issues, so there will not be any problem at all. So if they're facing any issues, the senior team members will be giving some suggestions to improve that or to replace some components in the architecture design part. Okay, so that's why in the iterative process, the main thing is it depends upon the prototype as well as the demonstrations. And also in the previous software systems, mainly we know that the some systems will be very less powerful compared to the present days. So in the present days, we have the most powerful systems will be having, and the architecture also we are having the parallel architecture. So it will be very simple, and the information will be represented passing very a fraction of seconds compared to the old systems. Okay, so here we know that we have the various types of the architectures are there, and compared to the here the single computer and single program systems and mapping. So how we are going to map the systems? So based upon the design and implementation and also the deployment. So we know, so we have different types of the architectures: SISD, SIMD, MISD, and MIMD. So here first, when they are considering the single computer and the single program, so they need to map the different types of the objects such as the design part, and they need to verify the implementation objects, and the last one is the deployment objects. So here these objects has to be mapped during this single computer and the single program. So when they're going for the multiple things, okay, they need to verify about the what is the complexity, because in the single computer, so they can easily map the objects like the design, implementation, and the deployment. So, but when you're coming for the multiple instances, so the complexity will be increased. So they need to check that what is the main advantages during the modern technologies. Like they need to check that what is the commercial components are there. So whether they need to implement the object-oriented methods, and they have any open systems, and they need to apply for the distributed systems or not. So what is the target environment and host environments are there. So what are the best programming languages, they need to implement it in the modern languages. So they need to verify. These are the main metrics or the measures they need to consider while they're designing for the multiple instances. So that's why here the complexity will be increased. So they need to take the different types of the metrics to improve, to take the considerations of these measurements and to improve for the modern technologies. And whereas here a model is relatively independent. When the model will be independent means, so when we are taking the abstractions, okay, so like whether we need to take the specific or whether we need to take the relevant or irrelevant of the data. So based upon the perspectives, we need to check that. So what is the model relativity, whether it is a dependent of the independent of the abstraction. So now we'll see the how the architecture will be the management perspective. So we know that during the initial stage only, the management first they need to design the software. So if they want to design the software architecture, so they need to design the architecture. So architecture is the main heart of the project. Okay. So here the most critical technical product of a software project is architecture. So architecture will be the main critical. So they need to take the different types of the considerations and what are the main various components and what are the different types of the automation tools they need to implement in the architecture, such as the structure, control, and data interface. So that should be permitted to the software components, and it has to cooperate. The different types of the component has to be cooperate to the system and software designers. So then only different types of the criteria of the team members has to be cooperate to each other, so that then only the architecture will be succeeding. If not, then it will be very complexity of the data here for the software project. So that's why when we can tell that architecture is having the both quality based upon the accurate and precise communications. Okay, so accurate and precise communications among the teams will be helping the people, whatever the problem it is. So when they are having some understanding between the team members, then they can achieve that architecture will be having the accurate and precisely, and they are going to improve the quality also based upon that how they are going to communicate within the organization. Okay, so here we have the communication media such as the multiple languages, and they can have the intergroup literacy. Okay, if they are having the communication problem during the project, so it will be going to the very extremely complexity and the problem cannot be unsolvable. So here we can take the different types of the use cases. The first use case is here, if there is no cooperation between the team members. Okay, if there is no cooperation between the team members, then the project cannot be solvable, or we can call as the unsolvable. Okay, or in the second case, team members are very intelligent and one team member cannot cooperate between these two members, then also the problem cannot be unsolvable. When it can be solvable means when three team members, means all the team members are having some understanding between from one member to the another member, then they can easily solve whatever the problem they can face here. So that's why when they're having some problematic in the project, if there is no cooperation between the team members, then the complexity of the project will be very high here and it cannot be solvable. So that's why in the team there is a cooperation between from one member to the another member. Then only they can resolve the whatever the problems or the complexity during the software projects. So that's why these are the main different types of the scenarios. Okay, we have seen that. So there should be a good communication between from team members and to resolve the complexity or the problems what when they are facing the projects. And also the software development team is to be success. When we can say that the software development team is success means when they're having the inter-project communications and they need to capture the different types of the software architectures that should be accurate and precise. So as we have discussed that different types of the case studies, when all of the members have the good communication and understanding between from one member to the another member, then we can say that the software development team is successful. If there is no cooperation, then we can say that it is an unsuccessful because the complexity is increased and the project cannot be solvable. So that's why there should be good cooperation between the software developers in a team. So then they can achieve the accurate and precise. Okay, from a management perspective, so they can have the three different aspects will be there for the architecture. The first one is an architecture, means architecture is nothing but there we can have that you can, so for example, if you are taking the considering the software, then we can have the intangible design. So there we can have the tangible and another one is intangible. So we know that intangible is nothing but it is a software related. Tangible is a hardware related. Okay. So when an architecture means intangible means, so they are going to design the software for the architecture. Okay, is the design of a software system and they need to oppose to the design of a component because it is an intangible because they need to develop the software for the for the design part, not for the components. So if it is a components, it is a tangible one. Okay, so then the management will think that here, so in the intangible, so they need to verify that all the engineering necessary. So what are the materials or the resources are there? So they need to check that whether they need to make or buy decisions are resolved or not. And also they need to check that the custom components has to be elaborated and what are the different types of the individual component cost and the constructions or the assembly cost. So they need to check that different types of the constraints of the resources or the requirements to design for the intangible design concept. And whereas the architecture baseline, so in the first point we have discussed that intangible, so that is software related. So tangible artifacts is nothing but mainly, so we can touch and we can sense. So it can be a paper or it can be a hardware devices. So there we can have the slice of information during this engineering handicrafts, so that mainly the ultimate goal is we need to satisfy to the all the stakeholders. Okay, so the vision statement has to be completed. So based upon the functionality as well as the quality. So they are going to consider the different types of the parameters and the business cases like cost, profit, time, the technology, and the people. So based upon these tangible handicrafts, so the management has to be satisfied all the stakeholders based upon these constraints or the measurements. So they need to take the different types of the business use cases to satisfy the stakeholders as well as the developers. The third one is an architecture description. Means here the human readable. Human readable when it comes means when you are considering the architecture and we need to check the in detail about the architecture because the human can easily understand the things very clearly. Okay, so here which is one of the components of the architecture baseline. So they need to, the senior members has to be inspect very clearly based upon the things of the architecture. The components has to be organized. So that's why they need to extract the different types of the shape models. So the human can be easily understand different types of the components as well as the sub-components of the architecture. And next one is here additional ad hoc notations. We know that ad hoc notation is nothing but the textual as well as the graphical. So when you're considering the paper is a tangible thing. So the some stakeholders will be acceptable the tangible one. So which is the data can be present in the paper. So the information can be very clarified and cannot be changeable. So that's why most of the stakeholders will be considering the tangibility. So that is consisting of text and graphics. And whereas the intangible, we know that only the related online. So there we can modify the things. So whenever we can, so we can update the concepts. Okay. So the architecture descriptions can be communicated in two ways. So one is intangible one and another one is tangible antigraphs. So there here, when you're considering the abstract, okay, abstract is nothing but here, there we can consider the different types of the forms in the different system domains. So there they need to consider the number of views and the levels. Okay, so example here, we can have the simpler form than the architecture. So there we can consider the motion picture, and they can have the products and different types of the biographics. So we need to consider that what are the major architecture, like whether they need to capture the motion pictures or they need to consider the different types of the products based upon the biographics. And also here sometimes we can have the architecture of a glider. So simpler form, or sometimes we can club the simple and the complexity of the architecture into the design part. Okay, based upon the antigraphs. Okay, so where we are going to implement these products. Okay, if it is a aircraft, so there we can have the simpler as well as the complexity of the antigraphs also. Okay, and when you are considering the architecture for the air traffic control, so we can have the different. So we can start from the small development tool, and we can from the small development tool to we can design this architecture in a complexity model. Okay, and we have some development process, like one is stable software architecture. So when you design the stable software architecture, so then you need to check that what is the critical. So whether they need to make or buy decisions has to be resolved or not, and they need to notify that whether this during the life cycle. So from one phase to the another phase, like engineering stages of the projects, and they need to discover and resolutions of the numerous unknowns, like production stages, and the management has to be predictable development plans. Okay, so the transition has to be from one phase to the another phase, and during the architecture representations, they need to consider some trade-offs such as the requirement and the constraints. What are the main requirements when they are facing the problem, and what are the main solutions, how they can resolve these requirements and the constraints. Okay, and here we have the architecture and the process encapsulations. Okay, so sometimes they need to take the high risk. Sometimes we can have the low risk as well as the high risk. If they not design the architecture properly, they may face high payoff or high risk. So it depends upon the communications among the individuals, teams, organizations, and the stakeholders. Sometimes when they not design the architecture properly, that is poor architecture in the immature process, so definitely the project will be failure. So that's why they need to pay high take, they need to consider the high risk here. So that's why while they're designing any architecture, they need to keep some points that the architecture should be very strong and it has to be acceptable by the stakeholders as well as the clients. Okay, and a mature process. So when we can say that mature process means when all the requirements has to be when you are allocating to all these requirements has to be allocated to the demonstrable architecture, then we can say that we can predict the plan and we can predict what is the cost here. So that's why here the mature process will be having that some intellectual steps, and we have some solutions for that particular problem. So sometimes we can consider the human, or sometimes we can consider the automations. So based upon the requirement and the constraints, so whether we need to assign this problem to the human, or we can have the process automations. So here in the mature process, so mainly they can require the human innovations, because human easily can understandable the things very clearly. Okay, so these are the references. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.